Alright, so for this problem here, we're going to do a test because what they claim here is that these pumps, 1,298 of them are not pumping accurately, and 5,696 were accurate. And the industry representative claims that less than 20% of the pumps are inaccurate. So the first thing is we assume that that whatever he says is true, or that the proportion is exactly 0.2, and we want to try to prove that it's less than 20%, which is his claim, so that's why that's the answer to part A, I guess you would call that first part. Now the second part, find the test statistic Z. So we're going to use the TI-83 now. Alright, so the first thing we need to know is that we have 1,298 pumps not working out of, and now in the total number is the sum of those two numbers. So make sure you read that. Some problems, this second number will be the combined number, but in this case 1298 are not accurate and 5696 were accurate. So let's go add those two numbers first. So 1298 plus 5696. So that means there's 6,944 total pumps. Alright, we need that number. Alright, so now what we're going to do is go use the calculator to do this. So I'm going to do stat, and we go over to tests, and we go down to one proportion z-test. This is a proportion because we're talking about 20%. 20% is a rate or a proportion. And it's just one proportion. We're going to do a z-test. Alright, so P0 here is what they claim that it should be, and it should be 0.2. Alright. Now X is the number that do not work. There's 1,298 that are not working, and N is the total number. So this is where you'll put the 6944. And then the last thing is, are we testing that the proportion is not equal? We're trying to prove that it's just not equal to 20%, or that it's less than 20%, or that it's greater than 20%. We're trying to prove that it's less than, so we need to choose that option. Then we go down to calculate. And so that gives us everything that we need right there. Alright, so our test statistic Z is this number right here. And we need it to 4 decimal places, so negative 2.724, and that 0 will wind up to a 1 because 8 is larger than 5. So negative 2.7241. And then the next part of the question, we have that as well. What is the p-value? And the p-value is 0.0032, and it will stay at 2. So for that one we write 0.0, what was 0032. Alright, so just to point out again. Now keep in mind that, that in this case p is the p-value. The p-hat is 1,298 divided by 6,944. That's what that p-hat means. So they claim that it's less than 20%. We actually found that 18.7% of the pumps are inaccurate. So what this is telling us is that yes, this is less than 20%, and this p-value is what really tells us is there really truth behind that? Is 18.6 a low enough percent below 20 to say that yes, we can say this without worrying about it. So because the p-value is, and in this drop down box you have some options less than or greater than, it's going to be less than the significance level, we reject is your option in this one. You can either fail to reject or reject. We will reject because this is less than the significance level. The significance level, by the way, in case you haven't found, is 0.05. If we're less than 0.05, we reject. And there is sufficient or not sufficient of your options there, and it's going to be there is sufficient evidence based off of this to support the claim that less than 20% of the pumps are inaccurate. Alright, so that's how you do that one there.